Module 6, Final Review, Hessian and BST, Binary Search Tree. Yeah. So this BST, Binary Search Trees. Yeah. All right. So for this part, review for the final, so I go through some of the relatively hard questions, or some questions I need to explain a little more from comprehension questions, quizzes, and homework assignment number 2. Yeah. So those questions are basically the source for our final exam questions. Yeah. I select some of them to explain here. Yeah. For each part, typically I use first 2 videos to do the review part. The third video, so I talk about, a little more new knowledge, but that part not covered in the final. But I think the knowledge is useful for you for future study. That's one. Another, you have a chance to take another quiz 6, so that you can drop your 2 lowest quiz scores. Yeah. So that's the reason we have a little more new material. But here I just, say another time, that material, that part, not covered in the final. Okay? Final only module 4 and module 5. Okay? All right, so let's start our part 8.1, comprehension questions for module 4, part 1. All right, the first question here, first I give you the question set number, so you can find it easily. And the question number also here, so you can easily find it. But in the answers, I only give you the answer numbers. Many times you may want to know the reason, how to get those answers. Here I use this review chance to explain the details. All right, so look at this question. When we do the insertion sort on an array with 4 elements, so this 4, here I choose a relatively small number. The reason, the larger the number, the harder the question. So I don't want to make the question too hard, so I choose this 4 number, relatively small number. How many comparisons do we need for the average case? Yeah. So look at this. We have 3 different cases we study: best case, worst case, average case. Among these 3 cases, the average case is the hardest. Yeah. So that's the reason, sometimes I may not give you such questions because relatively harder. Yeah. But I like you to practice a little bit. So here you can see in this comprehension question set, I give you 2 average case questions. So this is the first one. Yeah. Average case, basically, if you want to solve this one, you need to go through all the cases. Basic principle, go through all the cases. Yeah. Sometimes it could be very complicated, because there are too many cases. Yeah. So that's the reason it is relatively hard. Yeah. All right. But for this question, we do the average case in this way. Now, some way we can handle relatively easier, step-by-step average case. When we do insertion sort, so here let's record the insertion sort. So we do it element by element. Every time we insert one new element in the currently sorted array. Yeah. When we start with the first element. No sorting needed. It is sorted by itself. Yeah. Then the second element, we need to do the insertion to make it sorted. Okay? Yeah. So you have different cases. Then the third element, you need to make it sorted, right? Then you need to do comparisons, make it sorted. Then the last element. Then the last insertion, you need to do possible comparison. Yeah. So that's the basic procedure. Based on that, let us do average case calculation step by step in a straightforward way. Yeah. All right. Okay. First, no comparison. All right. Yeah. So we can use 0. Okay. 0 comparison. Yeah. The second element. All right. So now, one comparison, right? Yeah. No matter best case, worst case, you just do one comparison, make it sorted. Yeah. So the second one also easy. Yeah. Okay. 1. Yeah. So that's the reason you see 1 here. Okay. Yeah. Now, third element. Now, the third element. You need to consider several cases, right? How many comparisons? We need to do calculation, right? All right. Okay. So look at the number of cases we have. How many cases do we have? We need to factor in all the cases. Do not miss anyone. No. All right. Here, I want to say 3 cases you need to consider. One is this element is here, this slot. Okay. Second, in between. Okay, that slot. Then that slot. 3 cases. Okay. For each case, we need to know the number of comparisons we need. Okay. The first case, we need 2 comparisons. How about that? Okay. Compare both elements, 2 comparisons. The second case, we also need 2 comparisons, right? The second case. The third case, only 1 comparison, right? When you do the first comparison, it is greater than this largest element, then you're done. You know where you should place this new element. That's just 1 comparison. All right. Now you do the average on all these 3 cases. What is the average comparison number? 2 plus 2 plus 1 divided by 3. Yeah, that's the total number of cases. So you get 5/3. Okay? So this number, the second term here. Right? Yes. So that's simple. All right. Yeah. Now the last element insertion. Now I think you get the idea how to insert. Okay? The last step. All right. 4 cases this time. Case 1, case 2, case 3, case 4, right? Because this is the new element. This is the new element. Okay? Yeah. 4 possible locations you can insert this new element. For the first one, you need to do 3 comparisons, right? For the second case, also 3 comparisons. For the third one, you need 2 comparisons. For the last one, you need 1 comparison. What is the total number of, or average number of comparisons among these 4 cases? That's easy to do the calculation. 3 plus 3 plus 2 plus 3, plus 1, total 4 cases, right? Yeah. All right. 9/4. Okay. So that's the last term, 9/4. Okay. Yeah. So that's the way we calculate the average case number comparisons. Right? Step by step. This way, it is much easier to do the average case calculation. Yeah. This way. Okay. Yeah. Although there are other different ways, but usually other ways much harder. You know, other ways, so what I mean, you need to consider the overall possibilities, you know, each one, you know, that is very messy. Yeah, but this way, step by step, yeah, so we can control, you know, in a nice way. Yeah. All right, so that is the first question. The second one, yeah. So this one, it is not hard. The answer is pretty straightforward, but based on my experience, the missing rate of this question is really high. Yeah. So every semester, every time I teach this class, the missing rate approximately near 50%. Yeah, higher or lower, but around that 50% missing rate. You know, very high. Yeah. All right. So here, what I ask you, the precise formula. Okay. Yeah. Because usually when I give you a specific number, I expect a precise answer, not approximate answer, precise answer. Okay? Precise answer. But every time when I do my grading, I saw so many students give me asymptotic notation, this kind of answer. Yeah. Don't use this for concrete number. Okay? Yeah. For the general unknown number, you can use this, but n is given as a specific number, then you need to give me the exact number of comparison number. So that's one important point, because so many students miss this point. I remember I mentioned this a few times before. Still, in our homework question number 2, I saw several students, give me this asymptotic notation. Don't do it. You lose all the points. If you do that, you basically lose all the points, even no partial credit. Avoid that. Okay, so that's the first thing. The second thing, the formula, binary search. We are familiar with the binary search. So most of the students, so what they, based on their intuition, the worst case, the number of comparisons. So usually, they use, this expression, because it should be an integer, right? This expression, based on their intuition. So this comes from the intuition. Okay, we know our intuition, many times it is not quite reliable. And this one, very close, but not very precise. Not exact formula. Okay? Not exact. Okay? We can use it as approximate formula. But this question, I check your understanding if you know the precise formula. So that's my goal. Okay? The precise formula, there are 2 versions. So you can use either version. Both versions give you the same answer. Okay? So here, let me write it again. The first version, the one we used here, ceiling function, okay? Log base 2, n plus 1 ceiling function. Remember this plus 1. Here, that's the reason this 512, this number equals the power of 2 to the 9th power. Okay? So after you plus 1, you take the ceiling function, you will move to one number bigger because you round it up. You round it up. Okay? So that's the reason I choose this number. Okay, yeah, this number. The first version. The second version, 1 plus floor function n. Okay, so this time you do not do that parenthesis, but you need to add this one outside of the floor function. Yeah, two versions, and we can show these two formulas are the same. You need to do some math calculation, so you can get that. And you can see in our homework number 2, this formula is tested in our homework question number 2. The missing rate is pretty high. So I estimate around 30, 20 something, 30, that level. So you can see, this question is important, and I want to check this, similar question in the final. Okay, so remember, understand, practice. So you will see similar question of this type in the final. All right, next question. All right. So given an array with 57 elements. So this is a long question, but this one, I want to check your understanding of that 3-element partition to solve selection problem. So we did 2 methods. The first way is the 3-element partition. Second, 5-element partition. So this one, we want to understand that 3-element partition. Okay, a lot of detail, a lot of story, partition. All right, so a lot of detail, a lot of story. Another is 5-element. 5-element, I gave you the last question in the homework assignment number 2. So when I review homework question assignment number 2, I talk about that. And it looks like many students, large number of you, didn't understand the detail. All right. 57 elements. Remember, we organize in 3-element groups. So you need to know the detail of the story. Okay, 3-element groups. Okay, how many groups do we have? 57 over 3, right? So 19. 19. All right. Okay. All right. So 19, odd number, right? Odd number. All right. So you can see there is a middle row, 1 row in the middle, 9 at the left, 9 at its right. Okay, in that way. All right, I will go find the 33rd smallest element, the rank number 33. Rank number 33. Okay, so we know that. When we do partition, we need to use this number to tell us which subarray should be dropped. Remember, we have a partition element. Our partition element is M star, okay? Median of the medians. All right, median, based on our story, median of the medians. All right, okay, we will see that. All right. So we find partition element. So this M star is 25th smallest. So its rank is 25. Rank number 25. Okay. 25th. Yeah. All right. Now the current rank number 33, right? That means we have two subarrays, one, another one, but this one also should be dropped. When we drop, we should drop all the left subarray part, including the partition element M star. Okay, so that's the elements. After one comparison, we should drop that. Okay, so we keep this right subarray. Yeah. So now the answer. How many elements are eliminated after first comparison? Yeah. So this number, 25. That's the reason. All the elements at the left-hand side of the partition element M star, including partition element, could be dropped, should be dropped. That's the answer. So you can see this is a very straightforward question. You do not need to go through a lot of details, right? Because in our algorithm, we have a lot of details, which part greater than, strictly greater than, less than, we have a lot of details. But in this question, I didn't ask you that kind of detail, right? So the answer is a straightforward question. Okay? Yeah. All right, so that's this one. Yeah. The last question of this part, another average case efficiency question. Okay, another one. Yeah, usually for a question like this, relatively hard. Yeah, but this concept is so important. Okay, so I plan to give you one question in this topic in the final. Okay, one question in this topic. What topic? Average case efficiency topic. This topic, you will see one question in the final. Yeah. So try to do good preparation on it. Okay. All right. Draw a decision tree. Yeah. So this one a little harder than the previous one. The previous one we can, do step by step easily, right? Here, this one, we need to do some characterization, try to, use several categories to organize the cases. Yeah. All right. When we merge two sorted arrays, regarding the merge sort in this homework assignment number 2, large number of you did not do well. Yeah, question number 23, 24. Yeah, those two questions, or 22. Yeah, those two questions. Yeah, large number of you didn't do well. So I will talk about those two questions in, another review session. Yeah. All right. Yeah. With each two elements, only two, merge two sorted array, each one only two. I try to make it as simple as possible. What is the average case efficiency? So you basically need to consider all the possible cases, right? Yeah. All right, so here, let's assume we have two sorted array. The first one, A1, A2. The second one, B1, B2. Then we do merge operation based on the values of these, 4 elements. There are many different cases. So usually it is not very easy to use different categories to organize those cases. Yeah. But we try to find a good way to organize all different cases. Then we can do the average. Yeah. All right, so let me work on it. Yeah. First, when we do the merge, now, first let's consider, we try to divide it into different cases. Yeah. The case one, okay? Case one, can we assume, yeah, because here, B1 element, let's look at what could be the possible location of the B1 element after, some comparisons, in these places. Yeah, B1. Yeah. So you can see the first case is we have B1, A1, A2 case. Okay, the first one. All right. The second case, A1, B1, A2. How about that? Third case, A1, A2, B1. How about that? In this step, we do not worry about B2. The reason is we want to make it as simple as possible. If in this step you factor in B2, it could make the discussion very complicated. Yeah. So in order to make that the first step easier, we do not consider B2. No. All right, the next step, subcases. Then we factor in B2. All right. Okay. Now, inside case one, what's the possible B2? Yeah. B1, B2, A1, A2, right? Yeah. Then another possible case is B1, A1, B2, A2. Okay. Another possible case, B1, A1, A2, B2. You can see, that's for the, then look at this, the cases. Yeah. A1, B1, B2, A2. A1, B1, A2, B2, right? That's all we have. Yeah. So this last one, how many cases? How many cases? Only one, right? A1, A2, B1, B2, right? So that's all the cases we have. Yeah. So you can see 3 cases here, subcases here, 2 subcases here, 1 subcases here, total 6 subcases, right? Yeah, total 6 subcases. That's the reason the denominator is 6, the total number of cases. Then we need to look at the numerator. Yeah. For each subcase, how many comparisons do we need? Yeah. So look at this. All right. So for this case, we need to do comparison. How many comparisons do we need? B1, A1, right? So B1 greater than A1. For merge, B1 compared with A2 greater than that. So for this case, we need 2 comparisons. Okay, so I use a different notation. Then for this case, yeah. So B1, right? So B1 greater than A1, but B1 less than A2, 2 comparison already, right? All right, so yeah. Then B2, yeah. Okay, B2, A1, then B2 less than, so 3, right? So you have 2 here, 2 here, right? Plus B2, another one, so 3 comparison here, okay? All right. Already that, also 3, okay? Yeah, 3 comparison here, okay? Yeah. All right. Then look at that. Yeah. The first one, B1 less than A1, 1 comparison, right? So B2 less than A1, another comparison. So 2 here, okay? Yeah. B1 less than A1, one comparison. B2 greater than A1. B2 less than A2. So 3 comparison. Yeah. This case, 3 comparisons. Yeah. The last one, B1 less than A1. B2 greater than A1. B2 greater than A2. Also 3. All right. Yeah. So now you can see for all the 6 cases, 2 comparison appear twice. 2 comparison appear twice, 2 times 2. 3 comparison subcases appear 4 times, so 3 times 4. Yeah. So that's the reason we get that formula. Okay, yeah. It is relatively complicated, relatively more complicated. So I believe most of you, after you see the formula, you couldn't understand how do we get that, because there is so much detail here. Yeah. Basically, we try to organize our data in different cases, yeah. Subcases. Yeah. The bottom line, we do not want to make our discussion very messy. Yeah. So we want to make our discussion very, well organized. Yeah. So here, that's the way we do that. Yeah. The procedure relatively complicated, so that's the reason for a question like that, I give you the data size relatively small. So I hope you can handle that. Okay. All right. So that's the last question of this part, 8.1. Yeah. So we stop here. Yeah.